I'm really pleased to, I mean, totally honored to introduce Jessie. Jessie Snedeker is a professor at the Department of Psychology at Harvard University. I asked Jessie how she came to know Ira, right? And she recalled that it was at a BUCLD conference, maybe shortly after the publication of Ira's 2001 paper. Ira was a friend of Julian Mussolino, yet another person who's been, a catalyst and pivotal in all of this. Jessie sort of like, noted that he was a very intelligent, funny, and friendly guy whose work she kind of knew about, but she didn't have, a personal connection to the work at that time. But soon after, Jessie was joined by Yiting Huang at Harvard. We saw a photo of Yiting talking at Cambridge that Richard shared in the beginning. So Yiting joined the Harvard group, and here I now quote Jessie, like everyone at Harvard back then, we were interested in the acquisition of number words. Right, so Jessie and Yiting, they were exploring ways to test whether children assigned exact meanings to numbers as soon as they could reliably use them. And Yiting started attending the Experimental Pragmatics conference, the one in Cambridge. And here Jessie continues, at that point, we were still focused on the question of number word meaning in children, but we quickly learned that folks were more interested in the sum control condition. So we took a long walk down a different path. And here I will add that, it's been a most fruitful and influential path, even though they went down the path exploring the control condition that the other folk were kind of fixated on. Yiting and Jessie published groundbreaking eye tracking work in their very well-known 2009 twin papers in cognitive psychology and developmental psychology, one with adults, one with children. And so then since then, Jessie with Yiting, but also with Josh Hartshorn and with other colleagues, have been leading the way in understanding the processing and acquisition of pragmatic meaning, not only through papers reporting original research, but also, I would say, very much so through wide view reflective work, which takes on board and synthesizes where the field is going. So today, Jessie is going to talk about Older and Wiser, 20 years of research on the development of scalar implicature.
Thank you so much, Napoleon. I'm really glad to be here. So the starting point for my journey, the primary observation we're starting with today is Ira's 2001 paper, which I take it has inspired this entire session, when children are more logical than adults. And I will give you yet another example of the basic phenomena that he was exploring. If you were, say, a student in my Developmental Pro seminar, and you came into my class this week desperately looking for your response paper, which I haven't returned, and you asked me, have you graded the papers? And I told you, I've graded some of the papers. You would probably infer that I had not graded all of them, and that is why I hadn't returned them. In fact, I'd be lying to you. I haven't graded any of the papers, but let's put that aside for right now. If you later learned that I had graded all of the papers, I guess you could say that what I said was literally true, but it'd be pretty bizarre. In fact, maybe even deceiving. What Ira found so many years ago is that children seem to behave very differently under these circumstances. They often accept underinformative scalar descriptions. So he observed that they accepted descriptions with might in contexts where must applies. They accepted descriptions of some in contexts where all applied. And other people immediately jumped on this observation, finding that extended to other scalar terms like or being accepted for and, started being accepted for finished. What I'm going to do today is a couple of things. One, I'm going to just try to embrace this question of why children often fail to make scalar implicatures. I'm going to give you a whirlwind tour of 20 years of research on this topic and end with my particular take on it, which is only one of many possible takes. I hope this doesn't get too redundant. I hope I don't bore you. But if you feel like you have heard this before, I'm going to tell you when to wake up, because at the very end, I've got some fun new stuff, which is, I think, a little tangentially related, but maybe you can help me think about how it's related. One is a paper that we just have under review right now about quantifier use in emerging sign languages. And the other is a bit of data that was collected in my lab about 3 or 4 years ago now by Lane Stranahan, which I still haven't completely wrapped my head around, processing evidence for the speaker as a listener. But let's start out with that primary observation. First, even though it's already been said, I've got to remind everybody here that anytime that I have thought about scalar implicature has been under the direction and guidance of Huang, who began this research program at Harvard and has been involved every step of the way. I think Yiting and I may have the longest kind of collaborative publishing record coming out of graduate school because she just hoarded data. There are still data sets that we have not published. As you will see in this talk, I actually found one I thought was very relevant. Maybe I can coax her into publishing it now. All right, so you remember that the observation was children accept underinformative descriptions. And I think the initial hypothesis that many people in the field, particularly folks coming from linguistics perspective, the initial hypothesis they had was that maybe children up to a certain age simply lack the skill of making implicatures. It's a single discrete skill. That's why so many terms are showing this pattern. They acquire that skill and then boom, they're like us. This was a really attractive and fun hypothesis because it suggested that development could be a wedge for understanding what was an implicature and what wasn't, right? So folks like Uli Sauerland jumped all over this. Great tool for deciding whether the inferences we make about plurals are implicatures. Great inference for deciding whether numbers are, for example, like terms like sum. This, I think, was never actually a reasonable hypothesis given even the earliest data. There's just too much variation in performance to argue that there is a single skill that is acquired. When you look across the different tasks we're talking about today, the age at which children begin to succeed ranges from 3 to 10 years. There's enormous variation sometimes within a study across different scalar terms. And we knew from very early on that performance was highly task dependent. So we're not going to be talking about this hypothesis today. I think it's proven to be false. Instead, we're going to focus on 3 hypotheses that did have some traction during the course of the last 10 years or so. And we'll begin with one that I associate most strongly with Napoleon, which is the tolerance hypothesis. The tolerance hypothesis grows out of Napoleon's work with Dorothy Bishop, where he changed the basic judgment task in a fundamental way. Rather than giving children just 2 options, accept or reject, he allowed them to have 3. How ridiculously simple. And it worked, right? He said, reward the caveman for how good his description is. And he gave children underinformative statements, absolutely true and perfectly good statements, and lies, right? Like I graded some of the papers would be a lie. What Napoleon found is that when children were put into this circumstance, we're talking about 5-year-olds now, what they did was they used the scale to distinguish felicitous statements, underinformative statements, and false statements. Felicitous statements were given the biggest reward, underinformative were given the medium size or the kind of big reward, and false statements were given the very little reward. Notice that in Napoleon's world, everybody gets a trophy for showing up, right? We never punish that caveman. We just give him less of a good thing. Very sweet, Napoleon. All right. So the conclusion that came from this paper is that children are simply more tolerant of pragmatic errors. They detect the difference between underinformative statements and true statements. And this in a binary truth value task results in them looking like they're unadult-like, but in fact, they're just a heck of a lot nicer. All right. I think tolerance is definitely going to be a part of the story, but it can't explain everything that's going on. There's a number of tasks where children just flat out fail. So for example, going back to Yiting's earliest study with the box task, we found that children who were 2.5 to 4 years of age systematically failed to prefer subset interpretations of sum in the box task. So they had a choice between 2 items and they were actually at chance, right? Half the time choosing the box where Cookie Monster had all of them cookies, half the time choosing the box we had some. Another piece of data that I find particularly informative that people rarely mention is a study that was done on generics coming out of Susan Gelman's lab. I think it's important for a couple of reasons. What Susan found was that adults and children who are given universal statements like all snails breathe underwater frequently misremember those statements as generic. Snails breathe underwater, right? So they have this bias to reinterpret statements as generic. Now, when you give an adult a statement like some snails breathe underwater, they do not misremember it as generic, but 3-year-olds do. Young children systematically remember some statements as generic as well, which suggests that they aren't generating the implicature. Now, we're going to see some data a little bit later, which says, oh, kids just don't know quantifiers from a hole in the ground, right? And part of the evidence that these folks invoke, this is coming out of Mike Frank's lab, is that children don't understand negative quantifiers like none. But what Leslie and Gelman found is that the 3-year-olds did seem to understand no, as in no snails breathe underwater. They misremembered these statements as negative generics. Snails don't breathe underwater. So they're not just ignoring the quantifier, they seem to be interpreting it, but in the case of some, they're misremembering it in a way that's consistent with all. The final piece of evidence that leads me to think that children are not merely tolerant is the processing failures that Yiting and I observed. And critically here, I want to direct you to the final study of the developmental paper, which is a little bit different than the other studies. This is a study where adults actually eventually succeed in making the inference, right? We found that when adults were given underinformative sum statements and felicitous sum statements, they were systematically slower in interpreting the underinformative statements, consistent with the hypothesis that they had begun to generate the inference. Children, however, showed absolutely no difference in their interpretation of the underinformative and felicitous statements, suggesting that they never generated the upper bound. So the evidence here came from the viewing paradigm that I've talked with you back many times before, right? But they're slightly different trials. Here we had contrast between sentences like point to the girl that has some of the socks in a case where we were referring to a proper subset, and point to the girl that has some of the socks in an unfelicitous context when we were referring to the total set. And what we were looking at was shifts that occurred after you knew what the word was, that it was socks and not soccer balls. What we found with adults is that their shifts were systematically cleaner for the felicitous sentences. They were more likely to switch to the target for the felicitous, very unlikely to switch to the distractor. But that was not true for the infelicitous sentences. In those violation cases, they showed a lot of distractor switches still, suggesting that they had made the inference and were looking at the subset. In contrast, the kids did not show this pattern at all. There was actually no reliable difference between the two conditions, and if anything, the means are going in the wrong direction. All right, so I think there's good reason to think that something is going on beyond simply being tolerant. The second hypothesis has gained a lot of traction from Dave Barner, among many others since then, is the lexical scales hypothesis. The lexical scales hypothesis says that young children know the meanings of scalar terms, like some and all and none, right? But they do not yet treat them as part of a scale, right? They know that some has existential meaning, they know that all has universal meaning, but they do not recognize the relationship between those meanings. And this could lead to a failure to make an implicature on most pragmatic theories. For example, on the grammatical theory, this would mean that they do not generate them as alternatives for exhaustification. On a neo-Gricean theory, it would mean that they do not consider them as possible alternative utterances. One piece of evidence comes from a study by Barner and colleagues that contrasted sentences with sentences that had only some. So they had control true sentences like, are some of the animals sleeping, where a proper subset was, control false, like, are all of the animals sleeping, and underinformative some sentences like, are some of the animals sleeping when all of them are, and critically, an only condition for this, are only some of the animals sleeping. What they found is that under these circumstances, young children systematically said that the cases where the total set was sleeping were consistent with the only some sentences. And what Barner and colleagues said is that this means kids aren't just having a problem making the implicature. There's no implicature required in the only some case. They simply don't recognize that only is excluding the total set, is excluding all. And they contrasted this with an ad hoc scale where the critical sentences are the ones on the bottom, are only the cat and cow sleeping, where in fact the dog is sleeping as well. And there what they found is that children systematically rejected that description for that picture, suggesting they don't have a problem with only in general, they just have a problem here with only in terms with the scalar quantifier. So there's a few limitations, I think, to this study. The first is it assumes that interpreting only is going to be trivial at this age, but actually children are lousy, absolutely lousy at figuring out the scope of only clear through the school years. So for example, Peterson and colleagues found substantial improvement between 6 and 12 years of age, really the age range over which we're seeing substantial improvement in scalar implicature as well, or part of the age range. And this was particularly true when only was taking subject scope. A lot of times then children interpreted only as having verb phrase scope. Second, this particular task is kind of a nightmare in terms of determining exactly what only is taking scope over. Their intent was to exhaustify over some, with the alternatives being things like all and most. But of course, you could use that grammatically to exhaustify over animals or some animals, resulting in a whole nother set of alternatives in both cases. A third factor that I think makes this study very difficult to interpret is that when scope is ambiguous, as it is in this case, it's often resolved with prosodic stress. But the authors specifically state that they did not put stress on some in order to avoid any clues of that kind. And so I think it's a difficult study for kids at the best. Okay, let's come come back to the lexical scales hypothesis and the strong predictions it makes. I think the strongest predictions of the lexical hypothesis are that you should see better performance on ad hoc scales than you do on lexical scales, particularly at young ages, and that this difference between ad hoc scales and lexical scales should disappear after a given lexical scale is acquired. So for example, you might see better performance in ad hocs at 3 to 5 years of age when children are floundering with some. You might see that difference go away by about 8 or 9 years of age, and you shouldn't see a difference in adults if all that's required is learning the scale. However, when you look at direct comparisons of lexicals and ad hocs, the results are all over the place. This particular data set I think I am taking from Katsos and Bishop 2011 and their various tasks, right? What I'm showing you is the percent of rejections. So scalar implicature calculations for the 3 different tasks for both the sum and the ad hocs. And what you can see is that there's little, if any, difference here. And I think it's statistically unreliable. So no strong evidence for ad hocs being more implicature generating. In fact, if you look at earlier versions of the Katsos and Bishop task, which was done in a much wider age range, what you see is that there was a difference, right? There was an age at which children performed better on the ad hocs and the scalars, but it was 7 years of age. After we think that they recognize the scale itself, because we get above, way above performance, way above chance performance on the 3 alternative tasks. So I don't think that's compatible with the simplest version of the lexical scales hypothesis. There's other data sets that do seem like they're compatible. For example, Horowitz and Frank had a paper where they compared ad hocs like on my book, there are cats, which might lead you to book C because book B there in the center, right, has both cats and birds, with cases like on the cover of my book, some of the pictures are cats. What they found is that the ad hocs resulted in consistently excellent performance. Here we're comparing 2 age groups of 4-year-olds, young 4s and old 4s. But in the implicature trials, children were doing miserably. So the sum trials here. One thing I think makes this data set very, very difficult to interpret, and they certainly talk a lot about this in the paper and in their subsequent studies, is that performance on the none condition is also absolutely horrible. In fact, I think that the best way of interpreting over on the scalar side is that given these incredibly complex constructions with the moved prepositional phrase, right, and the complex noun phrase, children are basically looking at that final word, the book with cats, and then finding the book that has the most cats on it, right, resulting in this big noun phrase bias. So I think this is hard to reconcile with the broader evidence suggesting that children do understand negative quantifiers. All right. I want to point out that there's a couple versions of the lexical alternatives hypothesis. I really focus on the first, that children lack knowledge and must learn the scale. Other versions have been floated that they fail to retrieve the scale in some relevant context, that they fail to retrieve it quickly enough to use, or that they fail to generate composed alternatives based on the scale quickly enough to use them to make the implicature. Options 2 and 4, I think, are really another way of describing what I'm going to be calling the processing theory. At least they are consistent with or similar to a processing theory. So what's the processing hypothesis? All right, well, the processing hypothesis is grounded in what I like to think of as the 21st century standard model of language comprehension. On this model, we have to construct a series of linked representations going from phonology all the way up to pragmatics. We have to do it in real time as we are hearing speech unfold. And critically, we do incremental processing. We have ample evidence for this. The minute we begin to get information at the phonological level, we start to activate the lexicon. The minute we begin to activate lexical candidates, we begin to consider syntactic analyses. Now, we not only send information shooting up across these levels, we also, as soon as information begins to accumulate at a higher level, shoot it back down again. So if phonology begins to activate a lexical candidate, leading us to expect particular phonemes to appear later in the word, those phonemes begin to become active. If our lexical choices lead us to a semantic analysis, that leads us to expect, for example, an argument to a verb, that argument might become activated, leading to lexical expectations. All right, a second critical feature of this model, or third maybe we're on now, is that it is not isolated from the rest of the mind. We have ample evidence from eye tracking studies, from perception and action studies, and from neuroimaging studies that these linguistic levels have direct interfaces with perception and action, that we immediately begin to activate perceptual representations and in some cases, action representations too. So given this model, how do we think adults calculate scalar implicatures? Yuting and I have argued that there are 2 basic mechanisms that are used by adults. The first is a bottom-up mechanism. They hear the word some, right, out of the blue. Like if I just come to you and I say, some of my children are home today, right? They hear the word some, they retrieve its meaning. At that point, they activate the stronger alternative all, and each of these steps takes a little time, even though they're occurring in incrementally, right? They construct the enriched meaning by contrasting with all, and then they evaluate whether that's appropriate in the context. Now, I'm not arguing that this is a staged process, right? I believe the minute one of these processes begins, the others very quickly follow and are occurring simultaneously. But I do believe that processing takes time. It's not instantaneous, it's not magic. And so it's going to take a while for information to go up and for information to come back down. All right, so this looks something like this. As you're looking at the display, you hear the sounds, you begin to activate the meanings. That leads you to look at their particular referent. All right, the second process by which we generate implicature-like behavior, we can argue whether it's implicature or not, is a top-down process. A listener is aware of the situation that they're in. I think this is very compatible with ideas from relevance theory, for example. The particular situation that our listeners are in is they're seeing a display, right? So that's one kind of communicative context. The listener sees the display and they analyze it. They encode a message level representation of possible reference. They figured out the game. We're going to ask them to pick up girls and boys, right? So they encode it, for example, one of them as the girl with a subset of the socks. After they've encoded the referent in this way, the message begins to link up with lower levels of representation, semantic, maybe lexical, under some circumstances, maybe even phonological. Now, this top-down analysis, it's sitting there and waiting, right? You've activated different levels of interpretation based on your interpretation of that particular referent, maybe even the lexical level. Then along comes the sentence. You hear some of. At this point, those sounds, those lexical items can connect up directly, right, with the lexical item that you've already activated and can link up with particular references that are available to you. Under this circumstance, there's no reason why you have to go through a stage of interpretation where you're thinking of some as meaning some and possibly all. You're actually linking some directly up to reference that it might describe. I think if you look over the processing studies as a whole, they provide evidence for these two paths to scalar implicature. Typically, you see implicature taking time and effort, suggesting that it's often bottom up. Instant scalar implicatures, however, do occur quite reliably, quite robustly in a range of psycholinguistic paradigms, but I would argue that they only occur when pre-encoding of this kind, verbalization, is plausible. What do I mean by that? Well, let's just kind of look briefly at decades of research on the processing of scalar implicature. Let's talk about three kinds of studies. First, there are judgment studies. The judgment studies, speeded judgment studies in adults, consistently find that upper bounded interpretations are slower. Second, there are the dual task studies, which often find that there is interference for implicature when you add load to the system. That would be consistent with disrupting this bottom-up process. Third, if you look at the reading time studies, I would argue that across these studies, there's evidence for a period of time that is required to calculate the upper bound. And in the work that I've done with Josh, I think it's right around a second, for example, in his EEG studies. And it's not a second from when you get the evidence that the implicature is relevant or not relevant, made or not made. It's about a second from when you encounter that implicature trigger some. All right. However, there are also a number of studies which show that instant scalar implicatures can occur when pre-encoding is plausible, and these seem to be most robust in the visual world paradigm. So remember again, the visual world studies work with sentences like this: point at the girl who has some or two, all or three of the socks. We see people instantly looking at the total set. Some or two of the socks we see looks divided between, some of the socks we see looks divided between 2 and 3 there. This is the pattern that we get over on the left. You probably also know by now that a number of folks, starting with Dan Grodner in 2010, get a very different pattern. They get rapid disambiguation for both some and all. When you look across the studies and compare them systematically, the difference that pops out is that in those studies that have delays, you often have multiple ways of encoding the same reference. We're referring across different trials to the same set as some, 2, or 3 all. In contrast, in the Grodner studies, you get just the quantifiers being used. Okay. If you look across a very large number of visual world studies, there is a clear pattern that pops out, right? Which is in dual encoding cases, you get delays for implicature. In single encoding cases, you do not. The studies that are underlined are the studies that actually have direct contrast. I'm not saying that all of these folks argue for the same mechanism, but the data is certainly consistent with it. All right, so 2 paths to implicature. All right, what does that have to do with kids? Why have I taken you on this journey? Well, let's talk a little bit about children in processing. We know a lot about children's moment-to-moment language comprehension. One thing I think we know at this point is that they are less likely to verbally encode situations in a relevant way, right? And the argument I'm going to make is that therefore they do not get effortless implicatures. We know that they are pretty poor at using emergent top-down constraints in real time, poor at using referential context for syntactic ambiguity resolution, poor at using the plausibility of a sentence as a constraint for syntactic ambiguity resolution. This should slow down the calculation of bottom-up implicatures because you have to go and get that top-down constraint and use it. We also know that children are prone to commit very early to an interpretation, prematurely quite often, and loath to revise. So if you go to the Trueswell kindergarten path effect, for example, where children misanalyze a prepositional phrase and just don't get over it, right? They tend to reach decisions very spontaneously. All right, so I just want to look a little bit at this one claim that children are less likely to verbally encode in a relevant way and thus do not get effortless implicatures. Some of the evidence from this comes from looking at children and adults in single encoding contexts where we just use one term for a particular kind of display. Yiting and I actually accidentally created a study like this when we tried to extend our sum-all results to other scales like many, all, and start-finish. So we combined these two scales in the same study, but you could always tell from the stimuli whether it was a start-finish trial or a many-all trial. Thus, as an adult, you could quickly learn to encode the displays with objects as many and all. You could encode the displays with partially finished items as started and finished. And what we found is that under these circumstances, adults showed very rapid implicature. The lower bounded terms, right, were as rapidly interpreted as the upper bounded terms. So many and all looked the same, finished and start looked the same. So finished and start are the red lines, many and all are the blue lines, no gap like we get for some and all, right? And we expect this because it's a single encoding context. In contrast, the children showed the same pattern they've shown in all of our studies. A big gap, right? So here we're marking at the beginning of the quantifier or the beginning of the verb, a big gap between the lower bounded term and the upper bounding term. So the same pattern that we saw before, suggesting that even in this one single encoding context, they're not doing this pre-verbalization. So let's think about how this might play out in a truth value judgment task. Imagine that the child hears an utterance like some of the horses jumped over the fence. The semantic content is constructed incrementally and it's passed on for pragmatic and referential analysis. As the child is doing this, a salient referent is available in the context. It's in fact true, right? A bunch of horses jumped over the fence, not just some, but all of them. And then the child commits to this interpretation before the pragmatic processing is complete. An adult, in contrast, could solve this in one of two ways, and I think effectively. When they heard that utterance, they could do the same kind of incremental construction and pass it on for pragmatic and referential analysis. They would also find a salient referent event in the context that made the sentence true. But because pragmatic enrichment can be completed more quickly, adults are faster incremental processors, they may have the upper bound before they make that judgment. They don't prematurely commit, pragmatic processing can kick in. The second possibility is that adults in many of our studies may be solving these tasks top down. They may encode our stories in a task relevant way. They might be saying to themselves, yeah, I know how I'd summarize that study. I think Kermit should say something like all the horses jumped. They then hear an utterance like some of the horses jumped. They contrast it with their prediction. They recognize it's less informative and they reject it. All right, so if this kind of story is right, then what we should expect is that the degree to which verbal encoding and comparison of utterance is encouraged should affect the degree to which children make implicatures. Do we push them to do this kind of coding and comparison? Temporal properties of the task should also affect the degree to which children do implicatures. Do we give them more time cycles, more time for top-down processing? We should also see that the degree to which children can make referential commitments prematurely should affect the degree to which they make implicatures. If they can commit, if they can find reference quickly before the utterance is complete or while the utterance is unfolding, right, we might expect to see fewer implicatures. All right. So that is my whirlwind summary of 20 years of research on the development of scalar implicature. I think if it's okay with the organizers, I would like to continue on and tell you about two new phenomena. I still have about a half an hour, right?
You've got 20 minutes. Is that all right?
Yeah, I have 20 minutes and then we can stop for questions. Does that sound good? A little bit of questions? Awesome, Napoleon. All right, there's two things I want to tell you about. The first one, it's really short. Short to tell you about, painfully hard to collect the data. And it's about quantifier use in an emerging sign language. And there's a little bit at the end where it kind of gets us towards scalar implicature. All right, the basic question that we started out with in this study was, where do quantificational concepts come from, right? Where do we get them? Why do languages have them? And of course, we can't go back and look at how they came to exist in most of the spoken languages of the world. So in collaboration with Anne-Marie Kukob and Annie Tanenhaus, I was involved in a study where we looked at how quantificational concepts arise in Nicaraguan Sign Language. And this work is really Anne-Marie. She's been a part of the NSL group for about 12 years now. For those of you who don't know about NSL, it's Nicaraguan Sign Language, and it was created when deaf children were brought together for the first time for school in Nicaragua. Starting in about 1979 is when the first cohort enters. New groups of children have been added to the community consistently since then. And we can look at how the language develops over time by studying these different groups of children. So the history of Nicaraguan Sign Language really begins with a period before the creation of the school, where there are a number of home sign systems. Each child is in their own house attempting to communicate with their parents. And of course, the parents aren't terribly good at this, and the children generate their own sign systems. Then they come together in the 70s, they begin to form a language. That language is passed down to the new children who enter in the 1980s and in the 1990s. By convention, we typically study NSL by focusing on the group of children who came in the first 10 years as cohort 1, the next 10 years is cohort 2, the next 10 years is cohort 3. There's nothing magical about these dates, but it allows us to compare easily across studies. And we can analyze the data continuously as well, though, of course. All right, so in terms of thinking about quantificational concepts, we basically had two broad kinds of hypotheses. First, it's possible that quantificational concepts come from learning a natural language, that we have a language with some and all, we try to figure out what those words mean, and we engage in some kind of conceptual construction to do that. This is the kind of story that folks like, for example, Dedry Gentner might support, that relational concepts are built by trying to analyze your language. If this were the case, you might imagine that in a group of folks who does not have access to another language, it would take several generations for these kinds of terms to emerge, right? There'd have to be some sort of cultural construction process or discovery that led to them. Of course, another hypothesis is that quantificational concepts are a basic property of the human mind, concepts like some and all and none. And if that's the case, if they're just sitting around there waiting to get expressed, a part of how we view situations, then we might expect that they would emerge very rapidly in a new language. So Anne-Marie went to find out. She did an elicitation study with 28 users of NSL from the first 3 cohorts. And the elicitation was very simple. Actually, it has some things in common with that Snedeker and Huang task. We start with a group of animals that are all together, a group of objects, right? So we've got a bunch of bears then. And then we show the participant 2 possible transformations that could happen, right? In one case, there's a subset of bears that go into the water. In one case, all of the bears go into the water. Under these circumstances, oh, and then the red bar, the red circle goes around the display that the participant is supposed to try to describe. Their job is to get somebody else to choose the right picture of those last 2. Under these circumstances where a set transforms in this way, what we found is that speakers of full natural languages like English and ASL would basically say something like all of the bears are swimming, right, to describe that second set. We also had cases that were best described by none, like none of the boys climbed a tree. The vast majority of speakers of English described our last picture in that way. And we had existential cases, like some of the birds flew away. All right. So we're going to look at what was produced in each of these 3 contexts. And what we're going to do is every quantificational term that is used in each of these videos is going to be coded based on prior field observations. We're not assuming that those field observations are correct. We're hoping to discover whether they are correct. So for example, Anne-Marie walked in with a hypothesis about forms that were universal. And the question is, do the universal forms appear more systematically in the universal elicitation context? Here is what she found. In the existential context, she got all and only forms that she believed a priori would be existential. Okay? And there's a variety of these. We can talk a little bit about that later if you'd like. Cohorts 1, 2, and 3 on 100% of the trials produce putative existential forms. In the negative context, the vast majority of participants were producing one of the 2 negative forms that she had predicted. And interestingly enough, when people produce the existential or universal forms, they did it with a different predicate, right? So rather than saying none of the boys climbed a tree, they would say the boys stayed on the ground, right? Or all of the boys are on the ground. So perfectly pragmatically plausible, just not what we were after. And then in the universal context, something kind of interesting happens. First, notice that cohorts 2 and 3 systematically use universal quantifiers in this context, suggesting that we have correctly interpreted those forms as being universals. But look at what's going on with cohort 1. Cohort 1, most of the time, is using an existential form for what we thought of as a universal context. And this isn't because they don't know the universal form. In fact, all but one of them produced the universal form at least once during the study. So why is that? Well, there's a couple of conclusions that come from this. I guess the first is kind of obvious. Quantifiers emerge very early in a new language. 27 of our participants produced all 3 quantifier types. But then we also saw something we weren't expecting. The first cohort uses existential quantifiers in universal context. And this looks a little bit like scalar implicature turned on its head, right? They are failing to use, they're literally right. It's true. Some of the bears did go in the water. In fact, all of them did, right? So what it looks like they're failing to do is use the more informative term when it is literally right. This could have something to do with failing to understand informativity, right? I think it also could have something to do with an avoidance of semantic complexity. So quantifiers like none and all really have to be modeled as 2-place predicates, right? You can only talk about all of the bears are in the water if you're representing both the set of bears and the things that are in the water. But existentials you can model as 1-place predicates. You can basically think that the sentences might be something like, there are several swimming bears, right? It's really about the set of swimming bears and not about the set of swimming things and the set of bears. And so it could be this is an avoidance of semantic complexity. I don't think we really know yet. So that is mystery 1. Mystery number 2 gets at the heart of how we want to think about pragmatic processing. I'm going to switch domains now and talk about the Sedivy phenomenon, contrastive inferences from adjectives. Many of you probably know this study, right? Julie Sedivy did this great study about 20 years ago as well, where she had sentences like pick up the tall glass in contexts like the one on the left, right? And on the one on the right. These contexts are the same in that both of them have a tall glass and a tall pitcher. And the question is which you look at most, but they differ in whether they contain a contrast object to the glass. In the contrast case, you have a small glass. In the no contrast case, you have a completely arbitrary item like a book. What Julie found is that people were much faster to get to the tall glass, right? Looked at it more when there was a contrast. And this makes a lot of sense on a Gricean perspective, right? We might be thinking about why someone is saying this. We might say, she seems rational. If she wanted me to get the picture, she'd just say the picture, but she didn't say so. So she must want the tall glass. Tall must be referring to the glass. This is really a story about representing another person's mental state. What is the speaker thinking that you think? Now, if that's the case, if this is about representing other people's mental states, then it should depend upon the person whose mental states you're representing. Who is the speaker? What do they think? And Julie and Dan did a second lovely study where they manipulate exactly that. They create an unreliable speaker, and they used a whole bunch of levers to make you think that this person would be unreliable. They had a cover story that looked roughly like a description of Asperger's. The person was massively over-informative in other contexts, and they made a lot of lexical errors. And under these circumstances and subsets of these circumstances, what they found is that the contrast effect went away. Unreliable speakers did not produce a contrast effect. All right, so this is consistent with the story that what's happening here is speaker modeling. And in the one case, you're modeling a rational speaker. In the other case, you're modeling an irrational speaker. But I've always worried that it's also compatible with another story. Maybe all we do in these rapid disambiguation cases, these rapid pragmatic inferences, is model ourselves. We use the products of our own mind as we are thinking as a proxy for other people. And what happens when we learn that someone's unreliable is we just give up the game entirely. We stop modeling them. So either I run my own mental processes and use those to make predictions, or I give up on the game. I can't understand someone who's too radically different from me. How would that look? Well, imagine that you are sitting here looking at this display, listener as speaker. Right? You see these objects and you conceptually encode them. And when there is a contrast set, you yourself in your own mind encode the glass as a tall glass and the other glass as a short glass. The contrast changes the way that you conceptualize the problem. Now, if you then assume that the speaker is like you might use these conceptualizations, right, as you are listening to the input, such that you get the same kind of top-down inference making that we saw in the scalar implicature case. In contrast, right, if the speaker isn't like you might just throw out your own conceptualization and do everything bottom up. So Lane Stranahan looked at this, tried to tell the difference between the speaker modeling and listener as speaker theory. And she thought that working memory manipulation would be a good way to do this. On the speaker modeling story, you might assume that making the contrastive inference requires working memory, and it will go away when working memory load is high. On the listener as speaker theory, you might assume that overriding the contrastive encoding requires working memory, overriding your own beliefs, and you would expect the reverse pattern. So the task is simple. You get a memory task, then you get the Grodner and Sedivy task, and then you get a memory task again. Think Marty and Chemlaw meets Grodner and Sedivy. All right, our predictions are really simple. In the low load case, both theories predict that we will replicate the basic pattern that Grodner and Sedivy got. In the high load case, if the listener is the speaker, right, listener is acting as a speaker, then we should expect that that inference comes bouncing back in the unreliable case. We get the inference for both the reliable and unreliable speaker under high working memory load. The predictions for the speaker modeling are less clear. If we assume that speaker modeling takes working memory, then we should see a decrease in it, right, in the reliable case, and it should continue to be absent in the unreliable. If it doesn't require it, if it's an automatic process that is not effortful at all, then we might expect to see low load and high load condition look exactly the same. But critically, we never predict that the inference comes bouncing back under the speaker modeling condition for the unreliable speaker. All right, so here are the details of the study, right? We tested 136 people because these are between subjects manipulations of reliability and working memory load, with contrast manipulated within subject. The first thing to note is we did replicate the basic Grodner and Sedivy pattern. We got a contrast effect for the reliable speaker, no statistically significant contrast effect for the unreliable speaker, and we got the interaction that you would expect. The next thing to note is what happened in the high load condition. This looks like what we would expect under the listener as speaker theory. Specifically, there is a contrast effect. There is no interaction, and that contrast effect is significant for that unreliable speaker. And critically, there is also the three-way interaction, which, you know, those of you who are in this game know is kind of hard to get three-way interactions, particularly with a lot of between subjects variables. So we thought that was very persuasive here. All right, so the conclusion here for this subset is that language runs in both directions. And this may account for some of the facts that look like almost instantaneous, rich pragmatic inferences. And finally, I really want to thank you guys for 20 years of fun, and especially you, Ira.